Dear students, today we are going to derive a formula for the solubility of a sparingly soluble salt of weak acid in acidic solution. For that, let's take a salt Ma. This is our salt, which is a sparingly soluble salt. Definitely in the saturated solution, it will make an equilibrium. The equilibrium will be M plus A minus. Assume that the solubility of the salt is S, then obviously the molar concentration of M plus and A minus will be S and S. Now, if that is the case, then we can write the KSP also. KSP will be equal to, that is solubility product, that is equal to solubility of M plus into solubility of A minus. So I'll keep that expression. So I'll count it as equation number 1. Let it be there. So this is our equation number 1. Now A minus is a part of a weak acid. So definitely it will be doing hydrolysis also. So if it does hydrolysis, A minus in water can give you HA plus OH minus. HA plus OH minus anionic hydrolysis. Now, this HA is a weak acid, so definitely the HA can dissociate into H plus and A minus. H plus plus A minus. This is your hydrolysis part, okay? This is your hydrolysis. So, from here we can write the Ka of this acid, that is Ka is equal to concentration of H plus into concentration of A minus divided by concentration of HA. I'll call this equation as equation number 2. So we got two equations, equation number 1 and equation number 2. Now what we can do, we can write the concentration of A minus, or we can write S is equal to A minus, which is initial concentration of A minus after the dissociation of the salt in the acidic solution. So A minus initial, or we can write S is equal to A minus concentration, because this A minus is going for what? Hydrolysis. So there can be A minus in the form of A minus as well as in the form of HA. So we can write S is equal to whatever the S we are counting here. This S can be also written as what? S is equal to A minus plus concentration of HA. That is nothing but concentration of A minus initial. That will be separated because it is doing what? Hydrolysis. Now if that is a condition, from equation number 2, we can find out the concentration of HA. So if concentration of HA from equation number 2, if I add in this one, from 2, we can write, from equation number 2, we can write solubility is equal to A minus plus concentration of HA will be nothing but concentration of H plus into concentration of A minus divided by Ka. There is no doubt in that. It will be Ka. Now you can see that A minus is common in both the terms. So what we can do, we can write it as concentration of A minus into 1 plus concentration of H plus divided by Ka. Now we know that it is already mentioned in the first equation, equation number 1. We know that KSP is equal to, from this one we can find it out, concentration of A minus is equal to, concentration of A minus is equal to KSP divided by concentration of M plus. Concentration of M plus, we already know that it is S only, it is written here, S is there. So we can write it is KSP divided by S. Or we can write this is equation number 2. Equation number 2 is already done. So I will call this as equation number 3. Equation number 3. And this I can call as equation number 4. If I call this equation number as 4, then we can substitute, put 4 in 3. So if we put 4 in 3, we can write solubility S is equal to concentration of A minus. Instead of concentration of A minus, we can write what? KSP divided by S into 1 plus concentration of H plus divided by Ka. Or we can write S square is equal to KSP into 1 plus concentration of H plus in acidic solution divided by Ka. Or we can write S is equal to square root of Ksp into 1 plus concentration of H plus divided by Ka. This formula can be used to calculate the solubility of a sparingly soluble salt of a weak acid in acidic solution. I hope you're clear about this. And many questions have been asked from this particular topic in JEE mains and advanced. So have a look at it. Thank you.